All righty. So let's get into levels of measurement and IVDV stuff. So to use the tool, and by the way, so the tool really needs you to have this level of competence. So because some of the variables and some of the tests only allow certain levels of measurement. So what are we talking about here? So there's basically three levels of measurement of a variable. So I can have a nominal level measurement variable, such as gender, male, female, political affiliation, Republican, Independent, Democrat. So basically, the nominal level variables are just groups or just categories, okay? There's no hierarchy to them and so forth. They're just naming levels of a variable, as I just indicated. There are also ordinal level variables. Well, what's ordinal? Ordinal just means that it's ordered. And so the things can be small, medium, extra large. Things are in size order or in time order. There's lots of different kinds of orders. The critical thing about ordinal level variables is that the intervals in between them are not equal. So in a horse race, you can have the horse that came in first. You can have the horse come in, a nose later, which would be second, and then you would have a horse that comes in 16 lengths later, coming in third. So there's definitely an order, but they're not equally spaced, so to speak. Scale level variables, which include interval and ratio level variables, they do have names, okay? They do have order, and they do have equal intervals in between from one level to the next. So, and hence the icons of this nominal of like a kind of Venn diagram. Ordinal is just has it ordered, and then interval, on a measuring on a ruler, each one of those inches are equally spaced apart. Hammer this home a bit. Fruit, no particular order. Okay, just naming a fruit is the variable, and then you can have different names or categories. Ordinal just used the activity level, sedentary, moderately active, very active. Who knows? Sedentary, maybe no exercise. Moderately, maybe 3 days a week. Maybe very active, 7 days a week of exercise. So again, not equally spaced, so to speak. And then scale, your rulers, thermometers, all have these equal intervals in between. Okay. So if anyone has any questions about levels of measurement, feel free to put that in there. Okay. So, okay, let's move along here, and then I see some of these questions, the Q&A, those are probably helpful to lots of other folks too, so share that with others. Okay, let's talk about what kinds of variables, what types of variables these things are. So an independent variable is typically in research something that the experimenter manipulates or chooses. Okay, so if I wanted to look at, running a 5K by gender, I, as the researcher, say, hey, you know what? I want to be able to choose by gender or the variable that's what I mentioned looking at. Okay. And again, typically the researcher is doing that identifying. Dependent variables are things that depend upon the responses. So in a 5K race, the time it takes to run is going to be dependent upon the individual running it. So looking if the research question is, are there differences on running the 5K time to complete it by gender? The dependent variable, dependent upon the participants, is the time it takes an individual to run. The independent variable selected by the researcher is gender in this case. and say male or female or something of this sort. Okay, this is just another example. Here, I am looking at energy levels in terms of sucrose or something of this sort, of 3 different fruits. Okay, and I'm selecting the fruit, and then the fruit itself is the one that's actually showing evidence of how much sugar is in there. The last type of variable is really a covariate, and this is just things that I want to control for. Okay, some confounding variables. For example, if I was looking at run times by gender, but I noticed all of the males were 80, all of the females were 20, and I'd say, wait a second, maybe females are running faster, not because of the gender, but because of the age. So I want to neutralize the effect of that. So I could use age as a covariate, right? So covariates are things that we want to control for. Okay. So I think at this point, let's go ahead and get logged in to Intellectus. Okay. While you're getting logged in, and again, just if you're having trouble, put it into the Q&A, just to share some of the reasons why Intellectus was created, was that students and faculty really struggled with 3 things that I heard for a decade plus, which is they didn't know which test to conduct, which test do I use? They didn't know how to navigate the tool to incorporate assumptions, make tables, and so forth. And they didn't know how to interpret the output. So Intellectus really overcame those 3 challenges by having a decision tree to help figure out what test, easily able to conduct analyses, and then have interpreted output. So let me get logged into the right account. Okie dokie. So where should we start? Why don't we start with those last 3 questions that I just talked about, okay? So if I have a general example loaded up, I think you just select that. IVs and this looks like DV and IVs. So to figure out what test to conduct it and then interpret it, let's just say that I want to see if these 4 IVs, okay, do these 4 IVs predict, okay, or influence that DV? So I can go to the decision tree and say, well, I want to predict an outcome. That outcome happens to be scale, that dependent variable, 1 is scale. I'm doing a linear regression. So it streamlines the process to figure out what test. To conduct that test, once I've identified that data set, I just hit conduct analysis, and then I can just simply put in my variables. My dependent variable is identified DV1. My independent variables, okay, oops, I can identify there. That's all there is to conducting, and hit calculate. And the results you can see are right here. So the assumptions are built in to each one of these tests. And so we have a nice scroll over to help figure out whether that looks like a normal or non-normal plot. Ditto, there's other assumptions with scroll overs, other assumptions, outliers, and then the results are in pretty close to plain English. You have to know something, but it says, hey, there was significant, and it exemplifies how to report a linear regression in this case, APA table, And then you can see the interpretation. You can see that IV1 was statistically significant. And if we go here, we can say IV1 significantly predicted DV1. And then here's the interpretation part. Okay. This indicates that when you increase IV1, the DV1 will increase by 0.58 units, APA table, downloaded into an editable Word document. So that really captured the what do I do? How do I do it? What does this mean? Now let's just go much, much slower, but I wanted to at least show you that streamline arc of going from which test to what does that result indicate. All righty. So first things first. So for those folks that have data, first thing we want to do is go to projects. And we can get data in a few ways. For those that have data, you can go to enter data manually and just paste in a flat file or an Excel file. Or if you'd like to make up data on the fly, you can do that too. But you can do that in a manual fashion. For those that do not have data, you can choose an example data set. Okay? And I would suggest the masterclass. Well, there is a, hang on a second. I think we have under name. Yeah, you can just select the masterclass data set. That'd be fine. Okay, and just select that. And if you do that, just to create a project, and then your data is in there. And then we can play around with that data. Okay. Or you can upload data for those that have data. So we can just go to upload a data file. You can upload from different file formats. I happen to have one in Excel. I'm going to choose that file by scrolling down to, Rosenberg. What we've added here, so let's just go ahead and upload it. And I'll give everyone else a breath to identify their file, upload their file. And if you need an extra minute, just raise your hand and I'll slow down. Okay. So once data is uploaded, so the Rosenberg or lots of data that's really taken from Qualtrics or SurveyMonkey or other ones, it comes in like this, where you have the variable names up top. You may have the full question below it. And then you may even have levels underneath that, for example. The other thing is that sometimes the labels, this is a Likert type item or items, and sometimes the labels are sitting there rather than the numbers. We're going to want to have those numbers. So when we create a composite score, you have to have numbers to do that. Okay, so just to share with you what that looks like, I'll just also highlight that sometimes it's open-ended questions as well. This is not a deep dive into qualitative analysis, but I'll show you how we can structure some of that data. I just wanted to share with you what data sets looked like before. Okay, so the data cleaning wizard helps us shape that data in the way that we want it. So I'm just going to go ahead and click next. Well, let me just highlight this. It gets rid of those headers. It can update variable names. There's misspellings that happen sometimes between disagree with 3 E's and 2 E's and mail with a capital M and a small m. Converting Likert type items into numeric values, creating subscales and an ID. We can do this kind of quickly. So just go to next. So I want to get rid of these multiple headers because really all I need is the name of the variable. I don't need the whole question number. Okay, apply those changes. You can see that those were removed and go to next. Okay. Here, if there are labels with different spellings, like disagree and disagree. You can see the before and the after. And I'm going to merge those for each of the variables that have where the kind of AI is picked up the similar labels but misspelled. I do have Likert type items. I happen to have a 5-point agreement scale, and it looks like this, and I want to change it to that. Okay. So I'm just going to check all the variables that have these Likert type labels that I want like that. Apply changes. And then I'm going to go to next. I'm going to create a subscale. You're going to do a few things here. One is I'm going to name the subscale pretest. I'm going to choose whether I average them or sum them. Just follow the instructions from the survey instrument author. If they don't tell you how to create a composite score, I like to average them. Because if I have a 1 to 5 scale, I know a 4 means, hey, there's kind of agreement there. Okay. I know if they have a 1.5, they're kind of between strongly disagree and disagree. If I just sum them and I have a 9-item scale that goes from 9 to 45, and they have a 33, I'm like, I'm not quite sure what that indicates. So averaging them, I at least have a handle on how to think about it. So pretest, you identify your items, my pretest items. If an item is reverse scored, that is, you want high numbers to represent a lot of whatever that is, right? So if it's in knowledge, you want all high numbers to be high knowledge, okay, or a lot of knowledge. Question 2 could have been asked like, how little do you know about this? And they, mark a 5. So the test authors will indicate which one is reverse coded. And then you put in the min and max. And by the way, if any of the sessions today, if you have reverse coding, that would be great to show you that too, or look at the question. And if we wind up doing this in a consultation, can help you walk you through that as well. So at the moment, we're creating pretest, we're averaging those 4 items with one of them that is reverse coded, and I've identified the min and max of that scale. And I'm going to create just one more for the post test. I'm going to identify these 4 items. This one's reverse coded or asked in the opposite manner. We're going to average them. Apply and go to next. All right. You can add a ID variable, doesn't hurt. And finish. So here we have our, and then these are all changeable later, but at the moment, if it's a number, well, for example, ID, that's really nominal, right? The naming of those are just names. Okay. So, and I'm just going to hit continue. So basically nominal is name only, and we're just identifying what your ID number is. Age is well, really, this could be a scale variable. This is well, I'll change this. Let's just go ahead and do that. So age is really groups. So it's really ordinal data. And I could just go a little bit slow there. So I'm going to just click the caret down to ordinal. And I'm going to change this, go right into those levels and change it. 20 to 30, or 20 to 29, 30 to 39, 40 to 49, and then 50 plus. Okay. All right. And you could either make a brand new variable or just replace it in that existing variable, which is what I'm going to do. So you can see that we have an ordinal level age here. Then we have our let me just get the Excel real quick. Right, we went from these labels to numbers, allowing us to create composite scores, okay? Or average scores in this case. Okay. Then we have this other thing, which is open-ended, talking about leadership. One other quick thing I would do for data management is go to our text classification. So it takes all these open-ended responses and it will put them into different buckets or categories. And I can do this manually by selecting the number of categories or let the AI do some of that. Takes just a moment. Okay, and then here's my buckets. And let's just run descriptives on things, particularly the research variables. So go to analyses, go to descriptives, and then I'm going to select really what I'm interested in is age, sex, pre-test, post-test, misspelled there, and then my bucketed or categorized open-ended. So I'm interested in those variables. And what comes out is a descriptors for nominal and ordinal variables. And you can see the variable name and then the frequency and the percentage, okay? And for that open-ended, it, really categorized 20 open-ended into 4 buckets, with transformational leadership being the most frequent category. For the scale variables, we can see the means and standard deviations. And then we can run all the tests. So, okay. So let's see what we have here. So I think, Melissa, I just want to jump right in and just grab somebody. So maybe if Katie is available.
And then Katie, just raise your hand and we'll unmute you.
All right. And I'm assuming, okay, so we go back to projects and go back to Katie over here and load project. I'm going to take it over. The good news is once whatever we do here, it will be on her side. So, okay. So, hi, Katie.
Hi.
Happy New Year to you.
Happy New Year.
Thank you. All right. So, what do we have going on here? So, we have ID variables, nice, and then we have this looks
Encounter.
like what is this?
That is just my code for the encounter with the patient.
Perfect. And then we have length of stay, time on a ventilator, and then whatever CAM is. Okay, so this, what is CAM?
CAM is instances of positivity on a CAM ICU.
Okay, so that really is a number there.
Yeah, so 0 is not positive, and I think there's like 2 popped positive.
Right. So, okay, so we probably just want to describe that rather than use that. I'll give my, well, we'll see what the research question is. And then we have, so wait a second. So but this really is a number. Okay, so, and then.
I need to clean these up.
No,
I was in a rush and I just got them loaded.
Nope. So let me just see here. So this is 0, 1, and 2. So what are these exactly?
0 is they were not scored positive on a CAM ICU, and 1 is they were scored positive on a CAM ICU.
Okay.
And then if there's a 2 in that column, it means they were scored positive twice.
Okay. Pardon my spelling, my typing. All right, so and we probably don't want to mess too much with. We just want maybe just leave that. And then med vent, was that like a yes no or?
That was just me going through my baseline data and weeding out people who were ventilated for procedures.
Got it. Okay, I'm not going to mess with that.
I don't need to work with that in this.
All right. One thing I do want to do is see if, so I want to get rid of these, okay? Because it's going to mess us up. Because what we're really working with here is ICU hours and then time on vent, correct?
Yeah, my research questions are whether or not implementing the bundle of interventions decreased ICU length of hours and decreased time on the vent. This is all just my baseline data so far.
Ah, okay. So we're gonna have other data that is after the intervention.
Yes, sir.
So let's just do this for the fun of it. So I'm just gonna make a copy of this and I'll delete it right after. So I'm just gonna duplicate just so I don't mess you up over there. So med vents. So really a few things. So one is we want to get rid of this down here. So I'm just going to go to edit data, okay? And then just get rid of that, okay? We just want data in there, but not summaries and things of that sort, okay? That's one thing. The other thing we need to do is that we need to have another variable, and this is being recorded. So you need to have one variable, which is, let's just call it, time, okay? And these could be, pre-intervention, okay? All right. All right. And then you're also going to have post-intervention, okay? And then you're just going to add time here, add rows here, excuse me, add rows here of these things for the post-interventions, okay? Okay. So okay. And then I'm presuming that your post-intervention, you're hoping to have less time on a ventilator and less time, a shorter length of stay in ICU, correct?
And hoping for more CAM positivity. I'm
Oh,
assuming.
okay. 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 Okay, let's just call it positive. So so you're gonna be adding new rows, okay? And you're gonna add
Okay.
whatever their length of stay, whatever their vent time is, and what their cams are, okay? And then identify them as, post-intervention, okay? And basically, we're just gonna be doing like, you know, four things. So one thing we're gonna do, save. One thing we're going to do is we're going to go to descriptives. Everyone always run descriptives because if there's a problem, like for example, in the that summary data at the bottom, we want to figure that out before. So I want this. I want length of stay, vent, cam, and time. Okay. So I clicked on descriptives. I put the variables in and hit calculate. All right, I don't want this. What is this? Oh, a length of stay. I see length of stay should be, okay, I did something wrong. So this should be scale. I may have messed up here. Sorry. By the way, you really can't mess this up. So I encourage you to go in and play with it. And yeah. All right, so this is scale. All right, so scale, nominal, fine.
We
And
can get rid of med vent. It's not going to have any bearing on my outcome.
I don't think we're gonna get, we don't need these at all. Have to go into edit data. Yeah, I do like to keep the data clean. So you can keep this, that's fine. And then,
And we aren't going to need encounter really either.
okay,
That's just coded for me as I was
fine.
cleaning up data because I
Fine.
had to do a chart review on all of these.
That took a little bit of time.
It did, but I got 65 out of it and I started with 158. So we're loving it.
Good for you. Terrific, wonderful. Remove rows, okay. So, all right. Let's go back. So we are going back to analyses. And I'm going to go, we can go to here and we just go to edit. Here's our 4 variables. Edit the analysis. Okay, so for CAM, you have not positive and positive, frequency and percent, time intervention, frequency percent, and then the means and standard deviations for event time and length of stay. So the other test that you're going to want to do is 3 tests. One on length of stay by pre to post time, one on vent time by pre to post, and then CAM and time. So these tests are going to be the same tests. So these, let me just mess with the data a little bit more here. So I'm just going to edit the data. So I want these to be lower, okay? Post intervention. So length of stay. Wow, those are days?
Those are in hours right
Oh,
now.
okay. I'm
And
like,
I've
wow.
asked my
Okay.
site to
Okay.
double check and put it into hours and
No, that's
minutes, because I
fine.
think some of those are incorrect.
Um, that's where the I'm gonna save this. And let's go back and do the that's why demographics are so critical. When you do this, this has to make sense. That average score. If it's way off, okay, you want to correct it before we do any analyses, okay? All right. So here's the here's how we work through it. We're going to do t-tests, independent samples, because we're looking at differences on, let's just say, length of stay by time, right? Okay. And it's independent because the people at pre-intervention are not the same people at post-intervention, correct?
Correct.
They're different people, so they're different. If they were paired, if everybody was in the pre-group and the post-group, then it's a paired t-test, but this is independent samples.
And no one volunteered to be intubated again.
Pardon?
No one volunteered to be intubated again, unfortunately.
I believe that. All right, so for each of these tests, and it really runs the gamut of correlations and ANOVAs and t-tests, regressions, we'll get into chi-square and other advanced analyses. All the assumptions are built in. So here for the independent sample t-test, there's an assumption of normality. Basically what that means is that a pre-test, or pre-intervention rather, that length of stay, there's an average length of stay. And then there's some people or observations close to the mean, and then some that are really low length of stay, some with really high length of stay, and really that should look like a bell curve or close enough to it. That's an assumption of the test. So one was run for each one of the groups, okay? And then it has an interpretation. When that's significant, that means that the normality assumption was violated. We could talk about that. If you have over 50, you can probably waive that assumption, but that's just walking through some of what's happening with an independent sample t-test. Homogeneity of variance. Basically what that means is that the standard deviations at pre-intervention are similar to the standard deviations at post-intervention. They don't look close at all, do they?
No.
And in fact, that is statistically significant, and that assumption was violated as well. But again, if we wind up doing a consult, we could talk about those remedies. But basically know that you have to look at those assumptions. Okay. Then you have results, and the Welch's T is put in when you have unequal variances. Okay. So basically, we're once we are identifying that particular test, here is the write-up. The result of the t-test was significant. All right. And then here's the interpretation that the mean, well, significantly different between pre and post intervention, fine, but we can be more specific. Post intervention length of stay was much lower compared to pre-intervention. And then there's a bar chart. We could talk about this at some point, which is this is the test when assumptions are violated, looking at differences on length of stay by time with no assumptions. Mann-Whitney test. I won't get into that at the moment, but just to know for you that you're going to want to run 2 t-tests on ICU, the 2 scale variables, ICU and vent time, okay? All right. The CAM thing is a different animal. So the CAM thing is, that's nominal, and this is nominal. So here, let's just go to the decision. Do you happen to know what test that would be? I put you on a spot for a second.
For which?
To examine the relationship between CAM and time.
I do not.
Okay, so we can go to the decision tree and say, so I really wanted to relate those 2 variables. So relationship between 2 variables that are all categorical. Okay, and nothing is ordinal or any kind of ordinal, no. So that brings you to a chi-square test. It's not perfect decision tree, but and Melissa, maybe I need to be running a video on each one of these things to walk through each one. So it is a chi-square test, which is looking at the relationship between 2 nominal variables, or said another way, are these variables independent of each other or not? So I can just put those variables in, CAM and time, and run that. And I'm going to just run one more chi-square because it's a frequent enough test. Okay. And then let's just do, well, I think this is right. I think I may need it the other way. Hang on. Females, I think I need the hook there. Male. Female. I'm not sure I'm doing this right. Sorry. I don't think I'm doing this right. I don't think I have this right. Let's just go on to your example. Sorry. So chi-square, the first thing it does is identify the levels. Okay. So CAM, it's either not positive or positive, and in time, pre or post intervention. Okay. There's assumptions associated with this. And here is the kind of the table I was trying to make with Coke and Pepsi to make it more clear, but evidently I didn't make it more clear. Okay, so what's in this table? So we have CAM not positive, positive, time, pre and post intervention. We have 12 folks here that are not positive for CAM at the pre-intervention. We have 1 individual that was not positive at post-intervention. And then for positive, we have 5 individuals that were both pre-intervention and positive. Okay. Do those observations make sense to you? What's observed?
Yes.
Okay. What's inside of here is what's expected by chance. So it looks at row columns and column totals, row totals, and it comes up with a expected frequency, expected observations. And the question is, well, first we got to get through the assumptions. So the assumptions that all cells have expected values greater than 0, that's met. 80% of the cells have expected values of at least 5. All of them do. So those two assumptions were met. Okay. We can do other things if the assumptions are not met, but at the moment, those assumptions are met. So with the chi-square, we're just really doing two things here. One is we're saying, is that chi-square value significant? Okay. All right. And there's a calculation for that. And you just throw it into chat and say, what is the calculation? It's simple. What is the calculation for a chi-square test? And then once we have that chi-square value, there's a probability associated with it. If it's less than 0.05, we call that statistically significant. So that's part one, which is with regard to the results, is the chi-square significant or not? In this case, it is. Once it's significant, then we do the interpretation part, which is we compare the observed with the expected. So at pre-intervention, there were more not positive CAMs than would be expected by chance. Okay. At post-intervention, there were more positive CAMs than would be expected by chance. And those are the pieces of it. So nominal, or nominal and ordinal, chi-square test of independence, assess the assumptions, see if it's significant or not, and then compare the observed versus the expected frequencies. And that, what I just spoke, is sitting here in the interpretation. The following levels of combinations are observed to have greater observed values greater than expected values, okay? CAM, not positive, time pre-intervention, okay, and so forth. So it just lays out those 4 cells, okay? And then you download it and put it into your own voice and you're done, Katie. Okay, you're going to do descriptives, you're going to add extra data for post-intervention, you're going to do an independent samples t-test, okay, on the on length of stay and vent time by time, pre versus post-intervention, and then a chi-square, and we're there. All right,
Yeah.
questions you have?
This is fantastic.
Yeah, I mean, I've been timed and was able to do a whole results in 41 seconds. So I don't think I beat that time, but we're getting close here. So, but those are the things you want to do. Okay.
Sounds good. Thank you.
You're very welcome. So yeah, so that's what you want to do, and give us a holler if you need more help. Okay.
I sure will. Thank you.
Our pleasure. My pleasure. All righty. Let's just go to another one. Okay, so J. Rao at ASU, if you can hop on here, let's see what's going on. Okay, easy breezy. J. Rao, you there? Is
I'm
that
here.
Jennifer?
I'm here, yes.
Hi, Jennifer. How are you?
I'm good. How are you?
Good. Happy New Year.
Happy New Year to you.
So let me guess, you're doing a pre-post test.
I am, yes.
Okay, because that's the only data we have.
So I had a satisfaction survey that I did also, but it's on Microsoft Forms, so there's like a lot of information on it. So I didn't have time to upload that.
Oh, that's fine. You can upload it by going to edit data.
Okay.
And then just adding, columns or rows or whatever.
Okay.
Yeah, no problem. So yours is very simple. I still go through the same process of do descriptives on everything, then do your test, okay?
Okay.
So under analyses, oh, perfect. Look at you.
I was following along with you.
You don't need me. The one thing I would do though, one thing I would have done is I would have run descriptives.
Okay.
So that's my spiel that I want to run descriptives on all of my variables of interest. Okay. And then because if the min and max is 0 to 9, if I have a 10 here or 99, I want to correct that observation prior to running my t-test.
Okay.
So, and that comes out of decades of experience of not doing it, doing my tests, writing it up, only to find I made a data entry error.
Okay.
And maybe people are better about it than I am, but I made data entry errors. So you want to check that, okay? So that's the reason that happens. All right, so you did the test. The normality was violated. What is the sample size? You got a pretty good sample size. All right, so okay, so essentially what that normality and the parity test is really the difference between the pre and the post and plotting that those differences. Okay.
Okay.
That's why there's only one test here. Okay, but what do we got going on? So there is a statistical difference, okay, between pre and post. Nice following along there. And then because it's less than 0.005, it's less than 0.05. You can look at the effect size is good. I believe anything north of 0.3 is probably good. If I have that number correct in my brain. Yeah, and then pre-test was significantly lower than post-test, or post-test was significantly higher than pre-test. There's a couple ways to slice that apple. Okay. APA table and plot. So nice job. Except you have that business, right?
Yes.
So we could run that non-parametric test, also significant, okay? It's looking at medians, okay? And you can see the median is higher at the post than at the pre. So the question is, what do you do, right? So if you were at an R1 institution, I don't know where you are. If you were at a UCLA, whatever, Columbia, they're going to say you report the paired t-test, report that was violated, report this, and we're done.
Okay.
Hire a post-test. Excuse me. If you were at an R1, you would say was violated, then use the Mann-Whitney. Everybody else on the globe, and by the way, or for a journal article, you would want to probably just use the Wilcoxon. But for most things, no one's bleeding. It's not even a true experiment. They're not randomly sampled. And, I mean, typically, so I would just probably, what I would do is I would write up the descriptives in the paired t-test. I would share that with my committee. I would share that with normality was violated, and have the Wilcoxon in my pocket. If they said, hey, you know what, you should really run a non-parametric, guess what? I have that there. It was also significant, right? Okay. The story's being told, hey, guess what? Post-test scores are higher than pre-test. That's the story that's going to come out no matter which test. Okay. But I think for me, means are easier to talk about than medians. So, I know on a 0 to 9 or 1 to 9 scale what that looks like, okay? What that it's very challenging for me to say, well, the median is typically 7.5 is the often doesn't look that much different than 6, so I'd probably just use the means and move forward, but ask your advisors too,
Okay.
Yeah. All right. Great job following along. A+ there.
Thank you.
Yeah, nice job. All right, maybe take some questions. Do I have any questions here?
We've been answering them, so if you want to do another one, I know a few people shared today.
Okay, yeah, we'll do one more. Nope. I think that's it. I don't have any others.
Okay.
which is fine. So
If you shared your data and we didn't get to you, just put it in the Q&A. We'll make sure.
oh, you want to do that now?
No, I just want anyone that shared, if you shared it and we didn't unmute you, just put
Okay.
put a note in the Q&A and we'll make sure that we get to you.
Okay. All right, so let's just get back to this. Okay. And then do I have a contact info? No. So let's go ahead and put your contact info for everyone in the Q&A. Since I neglected to put that here, certainly info@intellectastatistics.com. We're happy for those faculty. We can provide trials, provide pilots, provide training, provide the courseware. I should mention that there's courseware available. They're competency-based lessons that go behind your LMS. Grades go to your grade books. You can, pick out of the 60 lessons, which ones you really want to present, and then we'll package them together. All right. Okay, so Ashley put her information into the chat. Any other final questions, thoughts prior to going on? We do, obviously we want to have institutions bring it into your departments. Certainly much more streamlined than SPSS, particularly if you're in professional programs. You don't really have time to take 5 stats classes or however many we can take. So it's, the right utensil for the right dish in the kitchen. This is the right use. Intellectus statistics is the right tool for many use cases. So that's something. For students, know that we also offer consulting. Yeah, you can contact Samantha. Maybe Samantha, you could put your information in there. So I would say faculty, contact Ashley. And then for students wanting support, you can contact Samantha. And I guess the last thing I'll say is that we also have two things I'll say. One is we also have a qualitative tool. So I know most folks on this call are probably quant, but if you know folks that are doing qual, certainly it's a tool that uses AI equally as friendly. And then finally, I would say tell others. We've been out there for a decade. Please tell others that you don't have to be stuck with legacy tools, and there's support to be had. So anyway, just to put that out there. All right. Okay, anything else? Any final thoughts from anyone?
There are a couple questions in here.
Yep. For a Likert scale survey, which test will we run for the data? So there's 2 parts to that question, really. One is Likert type with like 5 or 7 items of points on it. We consider that to be a scale. And then if you're doing paired Likert type, that's a paired t-test. If you're doing that by 2 groups, independent sample, like we did with Jennifer, or if there's more than, are there differences on whatever? Some score by a variable with more than 2 levels, like are there differences on income by political affiliation? I have Republican, Democrat, Independent. That would be an ANOVA. So I would just say to try to work through the decision tree. and knowing that you knowing that you know the levels of measurement of your variables, which I think part of the situation is that it's scale. It says it was shared, not pending acceptance. So, okay, so I can't get all of these. Again, if we didn't get to you, oh, here's something, and a speaker. I think I just caught this a little bit late. We run these every month. So I'm sorry, I'm just kind of getting that. Maybe I didn't refresh. Maybe I could just take 2 seconds with it. Hang on. Okay. And a speaker, let's just load it. Let's just take the last few seconds here. Okay, so alrighty, so let's you want to get her going on the phone here for a second?
Yeah,
And
just
a
raise your
speaker?
hand.
And then this will be the final. You snuck in under the wire.
It
All right.
actually took a while to upload because I did it a while ago.
Yep. So
It's
what are you
been
doing? Just kind of
pending, so
relating all of these things or looking at differences by?
So what I was looking at was the reflex lactate and whether or not it was done within 3 hours of the initial, and then whether or not that affected the length of stay. So I think I had 3 that were less than, but then 7 out of the 10 that qualified for the project were actually greater than 3 hours, making us outside our benchmark.
All right, so give me that first part of the question again. So you wanted to see if the reflex
Is completed within 3 hours of the initial.
do we want to look at the average reflex indicated by this variable? I think so.
Sure.
Okay, so that's one. So one thing we can do is okay, so I think you probably, so I like you doing this. Okay, so that's good. And then nice. Okay, so you got that going. So what you can do is just really look at a independent samples t-test on reflex, okay, by time within 3 hours, even with a tiny sample size. Okay, just run it. Guess what? Normality met. Homogeneity variance met. And no difference though, statistically. So those that had greater than 3 hours had a reflex indicated 3.59 versus 3.47, pretty close to each other. So they're not statistically different from each other there. So that's one thing. And then what was the other question that you had?
We were looking at the length of stay on whether or not people with higher lactates were had a longer length of stay.
Okay.
But looking at these numbers, it doesn't look like they did, but.
Yep. So there's 2 kind of things you could do there. So one simple thing to do is just run correlations, okay? And just run a correlation between length of stay and reflex. I would just do all of them for the heck of it, but those are the ones I care about. Is there's assumptions to be had. So this is the length of stay and reflex. R.17, it's not significant here, mostly because the sample size is small. But if you had 110, that'd probably be significant. Let's just see what that looks like actually. Correlations. Yes. Okay, so if you look at this, for 0.05, you can see if you had 125 people, okay, that 0.17 would be significant. So I think the thing to say there is, hey, gosh, it's not significant in this small sample, but you have a positive relationship, okay? That is reflex indicated is increasing, length of stay is increasing. Does that interpretation make sense to your brain or no?
No, I understand what you're saying.
But is that in actuality, do you want it to be positively correlated? Or
No,
not? Okay,
not necessarily, no.
okay, you want it the other way. Lower reflex equal, wait. High reflex is lower length of stay? How do you
No,
want?
higher reflex would be the longer length of stay. I'm sorry, I was backwards there, writing what you're saying at the same
Okay,
time.
okay, so that positive correlation makes sense to you.
Yes,
Terrific. Largest samples, it's called future research. Okay, you're not a multi-million-dollar funded researcher that can get, tons of people. So,
okay,
does this help?
yes.
Okay, cool. Any other questions?
I do not have any now.
Okay, all right. All right, well, terrific. Well, thanks for sharing your data. Yeah, I think that kind of gets at your two questions. And that's crazy surprising, even with the sample size of 3, that you can run things. But that's what it says. All right, terrific. Well, again, the contact information for trials, for demonstrations, for courseware, or for consulting is all in the question and answer. So thank you all for joining, and please do share our upcoming webinars and workshops with others who may benefit from it. So that being said, thank you, and I wish you all a very, very happy new year.